In this segment, we'll explore the installation and use of panmanUtils. panmanUtils is a powerful software toolkit designed to construct panmans and perform various functionalities on them. These functions include extraction of raw and aligned sequences in FASTA format, generating GFA and BCF files, and many more, as shown in the figure. And we'll focus on some of this functionality throughout the video. First, we'll see how to install panmanUtils. The installation of panmanUtils can be done in three ways. First, using the installation script, which requires sudo access. Users with sudo access to the machine can simply clone panman GitHub repository and run the installation script command to install panmanUtils as described here. If you don't have sudo access, installation can be done using Docker. Users can create Docker container either from provided Docker image or use a Docker file. In this video, we'll use the second method, which is installation using Docker image to install panmanUtils. First, users need to pull the latest Docker image on their machine using this command, which is also provided in the wiki. Docker image already exists in my machine, but it should not take more than a minute for a new user to pull the image. Next, users can create the Docker container from the pulled image using the command on successful execution of this command. It will take users inside the Docker container, which comes with pre-installed necessary tools and software, including panmanUtils, pangraph, etc. To verify if panmanUtils is pre-installed or not, move to panman directory and execute panmanUtils help command. This is how you can install panmanUtils using the Docker image on your machine and use it to analyze and build panmans. Now we will look at different methods to build panmans. Panman can be constructed either from a pangraph or a GFA or a multiple sequence alignment input. In this video, we'll focus on the construction of panman using pangraph. In this video, we are using 20 sequences of SARS-CoV-2, which can also be found in the test directory. Here, we provide raw sequences, pangraph alignment file, and a new forward for the SARS dataset. Now, to construct a panman from pangraph alignment, user can use this command, which is also provided in the wiki. Here, we pass input pangraph file, input nuke file, and the output file. While constructing a panman, an output file argument is a mandatory requirement. And pangraph construction is done. panmanUtils by default stores the constructed panmans in the panman directory, as shown here. So this is how panman is built using pangraph alignment and a nuke file. We also provide a Snakemake workflow to construct a panman from raw sequences. This is the Snakemake file for it. This workflow first builds an alignment file using pangraph or PGGB or MAFT and constructs the input phylogenetic tree using mesh tree. Note that mesh tree is only used when PGGB or MAFT is used to construct the alignment, as pangraph generation generates its own tree. Next, panmanUtil builds a panman using the alignment and the tree. Here we provide an example for building panman from raw sequences through construction of pangraph. Users can use this command to do so. But before that, conda environment needs to be activated. Then here User needs to pass the FASTA file for the raw sequences, number of sequences, and type of the intermediate alignment. And PanMan is generated. The generated PanMan can be found in the PanMan directory. Let's remove this file. And if users are interested in generating PanMan through an MSA intermediate alignment, users can simply replace pangraph with MSA. And the pipeline will use MEFT to generate the MSA intermediate file and then build the panman. We can again look at the panman directory and we have the panman. This workflow also allows users to build panman from fragmented assemblies and a reference sequence. Let's see an example. Here, we have a synthetic example of fragmented E. coli genomes such that each file has fragments of a single genome. Users are required to create a file that contains a list of all the files containing fragmented assemblies, which is target.txt here, which includes all the files, namely E. coli 1 to 4 of the fragmented assemblies. Finally, a reference sequence is also required, which will be used to find the ordering of the fragments, which is ref.fa here. Now users can use this command. Now, users can use this command to construct a panman from the fragmented assemblies we just saw. Here we're passing assembly argument as fragmented, frag, we are passing the reference sequence, and we are passing the target file. And we are using pangraph as the intermediate alignment. Fast forwarding to 2 minutes. And the panman is generated. It can be found again in the panman folder. These are all the methods to build panman. First, we saw building panman using panmanUtils from pangraph alignment. And then we saw how to build panmans using Snakemake workflow from raw sequences or fragment assemblies. Please refer to the panman wiki to learn more about them. Once panman is constructed, it can be loaded again into panmanUtils software to extract various useful information for downstream applications. Let's dive into few fundamental functionalities of panmanUtils. Table 1 lists all the functionalities supported by panmanUtils. First, let's look at summary extract. Summary provides node and network level statistics of the input panman, such as number of nodes and samples in the network, both nucleotide and block mutations count, and many more. To extract summary, Users can use this command where an input panman is loaded back into a panmanUtils and summary is extracted. As described before, summary reports total number of nodes and sample entry and nucleotide and block level mutations. Next, panmanUtils also allows extraction of raw as well as aligned sequences stored in panman. Raw sequences can be extracted using this command. Users can also store the output of any panmanUtils command into a file by just appending -o filename argument to the command. This will store the result into provided file name. By default, panmanUtils store all the functionality outputs into info subdirectory. Similarly, users can also extract multiple sequence alignment of the tip sequences using fast aligned. This will extract multiple sequence alignment of the tip sequences in the panman. Users can extract variations present in all sequences of a single panmet in a panman using this command, where reference is passed using this argument. Panman has a unique ability to extract variation among all sequences with respect to user-defined reference sequence in VCF format. This means user can use any sequence as a reference sequence in the pangenome and extract variation using this command. Again, this will generate the VCF file in info directory. As you can see, your reference is the one that we passed as the argument to panmanUtils. Let's use some other reference sequence to generate the VSF file. Here, now we have used a different reference sequence. As you can see, now the VCF is generated by using this sequence as reference. Another functionality of panmanUtil is that users can convert any panmet in a panman to a graphical fragment assembly, GFA, using this command. GFA has been generated and again can be seen in info subdirectory. panmanUtils also supports range queries. Users can extract alignments for all genomes in a panman based on input positions for a specified genome. To do so, users can use this command. Here, the range is queried from X to Y, and the reference sequence is this. So you can see this command extracts the alignment of all the sequences in the panman between 50 and 150 position of the reference genome. If user is particularly interested in looking at single genome between a particular range, user can simply change index no to yes. And this command will print the genome of the sequence passed to the reference between X and Y. These are some of the functionalities that panmanUtil support. Complete list can be found in Panman wiki page. And users can follow the provided commands to use these utilities. Thank you.